we talked about heating curves in the previous lesson. If you haven't done that, make sure you go back and check that. And now we're gonna look at heating and cooling curve calculations. So this will probably take 2 pages. But if we look at a heating curve, I'll just draw one. If we start here and we get to one part right here, and we get a nice short segment, and then we get another slope, and then we get another longer segment, and then we get a different slope. Now, normally these 3 slanted lines are different slopes, but they look kind of the same here. That's okay. It's just a model. But this would be the melting point, okay, and this would be the boiling point. And we remember that this is the solid, this is the liquid, this is the gas, right? And this is the solid plus the liquid, and this is the liquid plus the gas. Great. So a cooling curve, what do you think a cooling curve is going to look like? Here we have this, right? So a heating curve goes up. Where direction do you think a cooling curve goes? It goes down, right? So everything's in reverse order though. So now your short segment is the second one, right? So we have a gas here, and this is a liquid plus a gas, and then this is your liquid, this is your liquid plus a solid, and this is your solid. Again, they might just give you this part, or they might give you this part, right? It's your job to figure out which one is which, right? And we'll unlock that tool in a moment in a later video. But as we're just going to work on the calculations today. Again, this would be your boiling point, and this one would be your melting point. Okay, there you go. There's your whole review. There's more to it than that, which you learned in the last video, but now we're going to look at the calculations. So, we remember that lovely favorite equation, Q equals MCAT, correct? Q equals MCAT. Now that was, Q was heat, M was mass, C is specific heat, and delta T is one term. That's the change in temperature, right? So your change in temperature, remember temperature is your y-axis, there is a temperature change right here when it's sloped, and there's a temperature change here, and there is a temperature change here. So you are allowed to use the MCAT formula on all 3 of these places. That is perfectly fine. That is exactly like normal. All right. But if we notice here, there is no temperature change while we're still adding heat though, right? So we're not going to be able to use this. Since there's no temperature change, if we try to use Q equals MCAT here, delta T would be 0. The change in temperature would be 0, which means that our heat would be 0. We know that's not right because we are adding heat. So we have to use Q equals delta H times M, right? So that would be on the plateaus. So this green part would be on the plateaus. I know there's a lot of crisscross lines, but they're in different colors, so hopefully that helps. All right, now this one would be the delta H of fusion, and this one would be the delta H of vaporization, right? Vaporization because it's going from liquid to a gas. Fusion because it's going from a solid to a liquid, and you have to going this way, you would fuse those particles together, right, as a solid. So that's the way I remember that. But so those are all fixed numbers. So the delta H of fusion is a fixed number, and for water, it's 334 joules per gram. And then for water, the delta H of vaporization is 2,260 joules per gram. Now, we already have learned that the specific heat of water is 4.18, but did you know that ice has a different specific heat, right? That's 2.06. And steam also has a different specific heat, which is 2.02, right? So we will need all 5 of those in just a second. So for example number 1, we want to calculate the heat required to change a 25-gram sample of liquid water from 15 degrees Celsius to 75 degrees Celsius. The specific heat of water is 4.18. Piece of cake. So we're just changing liquid water from 15 degrees Celsius to 75 degrees Celsius. So that is probably about there and about there. We are only going one little segment and there's no phase change. So we'll simply just use Q equals MCAT like we normally would. We know that the mass is 25 grams. We know that the change in temperature, let's figure out what that is, delta T, is going to be 75.0 minus 15.0. Remember, final temperature minus initial temperature. And so that's 60 degrees Celsius, right? Good. And so specific heat is given to us. So we want to calculate the heat just by taking 25.0 times 4.18 times 60. And pardon me a moment. We'll take 25 multiplied by 4.18 times 60. And so it gives us 6,270. Should we do 3 sig figs? So we'll take the first 3, 1, 2, 3. And that last one needs to not be a significant figure, which it already is. So that will actually be a correct answer. 6270. No need to round or anything like that. Joules. All right. Great. Fantastic. Easy, right? Well, for example 2, we want to calculate the heat required to change a 5-gram sample of ice at negative 15 degrees Celsius to water at 15 degrees Celsius. So it's not as simple as the temperature change from here to here because we change from ice into water, right? So we have to first heat the ice, right? So that will be Q equals, and so the ice is going to go from negative 15 degrees Celsius to 0 degrees Celsius, right? Then we have to melt the ice, okay? Then we have to heat the water, and that's going to go from 0 degrees Celsius to 15 degrees Celsius. So each one of those is a different calculation. We're going to add those 3 together, and that will be the total amount of heat. Okay, so we have to do the calculation actually 3 times. So these can be a little long sometimes. All right, so we said number 1, we're going to heat the ice from negative 15 degrees Celsius to 0 degrees Celsius. So let's start there for, this is example 2. So we'll say example 2. Now the first part is we're going to heat the ice from negative 15 degrees Celsius to 0 degrees Celsius. So the change in temperature is going to be what? 0 minus negative 15, which is a positive 15 degrees Celsius, right? It went up 15 degrees. And we're going to use Q equals MCAT like we normally would, okay? Because we have a temperature change. Yeah, I should have noticed that. This is our game plan here. Since we're heating the ice, we have a temperature change. This one we'll use Q equals MCAT, right? And we have another temperature change here, so we're going to use Q equals MCAT again, right? Now, melting the ice, that's a phase change, right? So keeping with the color code like we were before, above on the, up here, right? So phase change. So phase change, we're going to use Q equals delta H of fusion times M, okay? That's the game plan. All right, so going back to where we were, Q equals MCAT. Where's my pen? There it is. I'm stuck. There we go. The mass was a 50-gram sample, and we need the specific heat, but it's the specific heat of ice, okay? So this is ice, so we're going to look at the specific heat of ice, which is right there. It's 2.06. And we are going to increase the temperature. We said the change in temperature was 15 degrees Celsius. All right, so the Q is equal to 50 times 2.06 times 15. And that's 1,545 joules. Keeping 3 sig figs? Yeah, 3 sig figs. So 1,550 joules. Okay. All right. Now, part 2. We're going to melt the ice. So we have to use Q equals delta H of fusion times M. This is actually really easy because the delta H of fusion is just a number, 334 joules per gram. And then the mass was, again, still 50 grams. The mass doesn't change. All right. So those two numbers multiplied together is 334 times 50 gives us 16,700 joules. All right. And as you can tell, the bell rang, so it's about time to start class. I'm going to see how fast I can go. We're going to heat water from 0 degrees Celsius to 15 degrees Celsius. All right. And so this is Q equals MCAT. All right. Like we said. Now the change in temperature is going to be, let's see, our final temperature, which is 15, and subtracted by our initial temperature, which was 0. So that's 15, right? Making sense. And so we're going to find the mass of that water, which again is still 50 grams. Specific heat of water is 4.18, right? It's right there if you forgot, but it's there. And then the change in temperature is 15 degrees Celsius. All right. So Q equals 50 times 4.18 times 15 equals 3,135 joules. Great. So, almost there. The total heat. Total means the sum. We're going to add them all together. So I'm going to add in, I probably shouldn't have rounded early. Let's round at the end. So I'm going to add in 1,545 joules. It took that much to heat the ice. It took this much heat to melt the ice. Wow, that took a lot of heat, didn't it? Yeah, phase changes take up a lot of energy, all right? And then it took 3135 joules here, all right? Fantastic. And we'll add those all together. Plus 616,700 plus 1545. It equals, and so we get our final number, 21380 joules. And now we'll round to 3 sig figs. So the first 3 sig figs, 2, 1, and then the 3. The 8 is going to round the 3 up to a 4. So it's going to be 21400 equals 21400 joules, which is the same as 21.4 kilojoules. Great. Fantastic. We did it. We made it all the way to the final answer. So that's just one phase change, okay? If we did 2 phase changes, if we started at ice and ended up at steam, that would actually take 5 calculations, 5 parts, 1, 2, 3, okay? So on the back, you have 2 problems. These problems are up to you. You now need to change water into steam, okay? So that will take 3 parts. Here you have to heat the water. The second part is to boil the water. And then the third part is to heat the steam. All right. And remember, we're heating the water from 30 degrees Celsius to 100 degrees Celsius. And then you had to heat the steam from 100 degrees Celsius to 175 degrees Celsius, right? So I leave the rest up to you, and you'll check your answer in Schoology. Now for problem 2, we want to calculate the heat change of 40 grams of ice at -5 degrees Celsius to steam at 130 degrees Celsius. So the first part is we're going to heat the ice from -5 degrees Celsius to 0 degrees Celsius. You now need to melt the ice. You now need to heat the water. From 0 degrees Celsius to 100 degrees Celsius. And then you will need to boil the water. And then you will need to heat the steam from 100 degrees Celsius to 130 degrees Celsius. So there's 5 of those right there. All right. Remember, which ones do you use MCAT? Which ones do you use the Delta H? All right. Have a great day, and I leave it up to you. Check your answers in Schoology.